Hey guys, the qualified labor crisis in architecture, engineering, construction, and supply chains, AECS, is absolutely real. We all know this. And if you're listening to me, then you're probably very passionate about technology in AECS. So, what better to talk about than the intersection of those two is actually fixing the qualified labor flight with technology? And the answer to that might be robotics. So today I'm going to share with you my framework of what I look for in robotics companies in AECS. Tune in. Hey guys, let's talk robotics in architecture, engineering, construction, AEC. Today I want to walk you through my framework, how I think about businesses, how I think about companies, the segments to attack in AEC, and the founders and their processes for robotics. I'm going to walk you through all of that step by step. Might be a longer episode, but I hope it will be an enjoyable one. So first of all, I want to share with you how I actually think about robotics in AEC. And so this is a very specific way how I enable myself when I look at a robotics company in the first place, whether it fits my interest or not from a capital efficiency and demand perspective. So if you look at this chart, imagine you would have a robotics company that pitches you that they can address a lot of demand initially with very little robotics development, and then over time the addressable demand would taper off, but you need more and more components. So this would be a very suboptimal case where basically the marginal utility would be constantly decreasing, and the marginal net profit that you can generate from scaling your company would be quite poor. So this obviously hopefully it does not exist. And if it does exist, please do not go after this. So this is just a framing that, if this is what you were going after, it would be quite suboptimal. A lot of robotics companies, when they pitch me scale, they say, hey, I'm going after this initial thing, and then I can do this and this and this and this. And so oftentimes the question that you have to ask yourself as a founder then, hey, is this going to be a linear function? Meaning you have to develop something new every time in order to unlock something new every time. And so there is a function here that could work, which I will talk about in a second. But if it truly in the end still remains a linear function between the hardware that you're building and the component library that you're building and the demand that you're addressing, in the end, you will not scale very efficiently and very quickly. So while it could still allow you to build an initial good company, it's not the scaling function that you would want. Now, you could think, okay, perhaps it's the other way around, right? So maybe we could actually build a ton of hardware, and in the end, it allows us to address everything. The problem with that is, in theory, that sounds good, but actually you would probably not survive the amount of capex and dilution that you need to put your investors through in order to get to the point up here where potentially you could be a net positive utility. And so that's something that, for example, I would say Katera actually was operating under this framework to a large degree. And so the death valley of, hey, my fixed cost, my capex, the dilution that I need to do, will I actually survive it? I would be quite doubtful whether that is an optimal way of doing it. So let me show you what I consider the most optimal way in AEC. So here what you're seeing is an S-curve function, and that's what I'm looking for. So an S-curve function means that you pick a very clear subset or subsegment initially, and you dedicate your development to that. But you don't have to develop a perfect, exhaustive component library, both in terms of hardware as well as in terms of software, to address that. But it gives you a baseline to then attack the next subsegment with lesser hardware or lesser new hardware and lesser new software. And so that's exactly the function that I am looking for. So let me walk you through the 4 steps that I consider ideal to build a large robotics company outcome within AEC. Start at the bottom right. So look in your robotics thesis for a narrow buy-ready AEC subset of your market that you can address capital efficiency. And usually that would be one workflow, one subset of a trade that you can do very repeatedly. Secondly, then what I will be looking for is a founder and a team that can expand their library of reusable, that is the important term here, reusable components, capital efficiently, because it's the reusability that actually gives you a scale function. So you will find scale on the demand side because you're growing in S curves, but the capital scaling that will come is from you building over time more and more components, but only the net new ones that you need while reusing a lot of the previous ones. And that's a software mindset translated into robotics. That leads me to step number 3, the software mindset and the product mindset translated into robotics. What I'm looking for is with the next workflow or trade or subsegment that you're attacking, I'm looking for a team that can build a dev engine, a dev process that consistently discovers and identifies and qualifies the next ideal workflow or trade or subsegment, and identifies how to repackage and reuse previously developed components, both hardware and software components, into a new one. Think, for example, like this. If you have developed a feeder system, a tower system, a mobile platform, you have developed a system in order to position and navigate in space, in order to identify with machine vision how to place all of these components. If you can find a way to think about them in a constantly repackaging way, will make the next S-curve to attack so much cheaper and so much more efficient, so much quicker and so much more defensible. And that is the function that I'm looking for. So that eventually, and that is the 4th step, ideally, because you do all these things, you're becoming the software company that repackages the hardware components that you have developed in a modular way. But because you're great at software and you're great at the dev process, you're great at discovering and qualifying the next subsegment in your S-curve, really what you're building is a robotics platform. But you're not building the platform because other people build on top of you. Maybe you do that, but that's not my definition of the platform in this context. But you're a platform because you can constantly load new processes and new trades while reusing what you have developed. And that's another way of defining a platform. So that's what I'm looking for. So I love to invest at the bottom of this when you actually attack your first S-curve and you're just developing your first component, but because I see the top part unfolding. And that sits in the subsegment that you pick, that sits in your mindset of how you design your dev process and what you represent as a founder. So these are the 3 things I now want to walk you through. My robotics framework, here's a subset of it. It's not the entire framework because in the end, I don't want folks to reverse engineer what I'm looking for, but it's a good set of it. So I look for buy readiness, which is the bottom left part. I look for success readiness, which is the top left part. And then I look for recombination readiness, which is the middle part. And if I see those 3 early in a company, I think it enables them to become a robotics platform in AEC. Buy readiness means that the work that the robot shall perform is something that today is bought as an outcome via a service or via a contractor very regularly. The buy processes and the governance is established. For the work also, there is a budget P&L line item in the projects regularly, and it's not hidden inside of another one. So for example, drilling holes for walls is not exactly that, because in most P&L budgets, it would not be budgeted. It would be budgeted as part of the wall work. So that is not something that I would be too excited about in the second point here. But I'm looking for the work that you can automate with your robot that in itself is a P&L line item. And finally, very important in buy readiness is that the way you deliver with your robot does not introduce questions about, hey, are they going to meet the norms, the standards? Is there potentially something about long-term durability? For example, if you introduce a new type of material that your robot will have to work with, sometimes that can raise exactly these questions. So that's buy readiness. If you satisfy these, it's a good subsegment to go after. Success readiness means that in the end, if you deliver an outcome, and I'm most excited about robotics going after outcomes rather than RAS, it is ideal from what I've seen if it has a functional requirement, but not a super high visual requirement. So if you wanted to go after perfect tiling with absolutely no splinters or cracks, etc., that has a high visual requirement. Perfect drywall finishing, the same thing. That is not ideal to go after. It can work, but it's not ideal. What's more ideal is if you go after the functional performance, But in the end, if there is maybe a slight crack somewhere or it's slightly imperfectly placed, that to the human eye, if you look at it, you're like, it's not absolutely perfect, but it doesn't have to satisfy the $1 million home kind of feel. That's pretty great in terms of success readiness. I'm looking for large homogeneous surface areas in relation to the edges or the corners. So if that ratio is relatively low, you will have too much work around the edges and the corners. But if that ratio is too large, you will actually have a negligible labor cost. So for example, asphalting 20 kilometers of highway is not an ideal case to go for as a robot, because that is a relatively easy to automate task. If you go after small room tiling, where you have, let's say, 5 square meter, 50 square foot bathroom tiling, that is also not ideal, because it will require you to work with too many corners and edges. So that sweet spot ratio, where it's a large homogeneous surface area to corners and edges, that's what you should be looking for, in my opinion. Now, I like highly repetitive functions in a highly repetitive sequence. So not just one step, but it's a step of tasks to make a workflow, and these are highly repetitive. I like repetitive site settings, but they are not perfectly controlled. So if it's not in a factory, that's actually a good thing, because that means you can build in some defensibility and some complexity, but in a hyper repetitive way. So that's what I'm looking for. And then finally, in terms of success readiness, I'm looking for value uplift. So if what your robot is doing is taking certain materials or components and assembling them into something else, I'm looking for a 100% value uplift, meaning the value of before the work is twice as valuable as the value after the work is twice as valuable as before the work. Or if you're not assembling something, but you're just maintaining or operating something, I'm looking for super high recurrence. Which brings me to the third and fourth element of what I'm looking for. So this was what's picking the segment. Now the recombination readiness that I'm looking for is how you as a team and as a company set up your dev processes. And I'm looking for founders that have a product background, building complex software, and who at the same time is great at sales. That's a very, very tough requirement and a very high bar to clear. I'm going to talk about that a little bit further. And because of that, they implement a constant deployment and constant component mentality from a software mindset into the business. And that unlocks the very quick iteration and dev processes that I'm looking for. In terms of buyer readiness and success readiness, here are a few examples that I have seen as interesting. Brick walling, doing the shingle roof tiling for single family homes in the US, tiling of big rooms where the visual fidelity doesn't have to be perfect. So that could, for example, be large warehouse areas or large factory type areas where tiles are required. Paving, window cleaning, painting are all falling into that. But you notice here that actually the work sequencing complexity becomes lower as you go down this list. And that's an additional element that you can keep in mind. So if you actually sit in the sweet spot between buyer readiness and success readiness, sitting a little bit more at the top where more work sequencing is required allows you to build more defensibility. So that's quite good. On the other hand, I wonder, actually, some of these don't fit my framework, and maybe they are still being built into big robotics companies, but I have my questions here. Drywall finishing. So here the visual fidelity requirement is insanely high. Sound barriers. If you can do it with concrete, it might not truly be automatable in terms of the value uplift that you can create. If you do it with another material, maybe it raises durability questions. So that's something to consider. Bathroom tiling in single family homes or pods. That's a question. If it is in a factory type setting, before you actually have to work a lot of corners of pre-built walls, maybe that still works. Then it could be more of a assembly line type setting. Rebar tying, welding, or rebar caging. I wonder, excavations, asphalting, these are trades that don't perfectly fit my framework. Maybe my framework is not the only one that can lead to success. But with my framework, I'm having questions about whether large outcomes in terms of robotics and AEC are possible in these segments. Now, let's talk about the dev processes, the recombination readiness. And so here, I'm drawing upon my colleague Gabe's work. Gabe's an aerospace engineer turned VC with us. He's also host of the Bit Builders podcast, the #1 AEC Robotics podcast. Tune in if you haven't seen it. And so I asked Gabe, hey, Gabe, describe to me what the ideal dev process in the early days of your robotics company in AEC should look like. And so he and I agree, making iteration inexpensive is very, very important. And in terms of numbers to look for here, you should try to find a way to build a prototype that is 10 to 15% of the cost of an eventual robot. In fact, one of the robotics companies that I've backed has a material expense of only $25,000 for a highly, highly advanced production-ready robot. And so that's the kind of mindset. If you make your robot, if you make each prototype cost you $250,000, it might not be inexpensive enough to iterate quickly. Which also means that you should go for off-the-shelf iterable components. So if you go for like bespoke hardware or industrial automation kits for your early days, that might not be ideal. You want to start from the simulation environment. So create an environment that you own and that you can build repeatable actions in, ideally. And so that is the point of, building a simulation environment and then actually owning that. So get a workshop, recreate the site that eventually you might be encountering on a repeatable fashion, but uncontrolled fashion. And then try to make one build per day. That's the dev process that I'm looking for. So build once a day, tear it down in the morning, rebuild. And that's how you learn and iterate very quickly, which also is then enabled if you build for modularity. So define the subsystems and run upgrade campaigns and don't get stuck with complex systems that in the end become very expensive to take apart, right? So modularity is key in your early days. And then finally, a very good trick that I learned is if you want to scale talent, so stick close to robotics labs. In Denmark, Odense is such a hub. Amsterdam, such a hub. In the US, you have multiple hubs like that. And then if you're really smart as a software founder, go for a programming language that has a cult following of hardcore people who love that programming language, but who is not widely used and widely adopted. Now, it might mean that you have to refactor later, but it doesn't matter actually. If you can gain talent very inexpensively and without competition, and you don't have to compete on salary, and you don't have to convince them every day to stay with you, or please stay with me, etc., because they are committed to your language, then that is actually a big asset in the early days and early years of your business. And then refactoring later is not that painful anymore. And then finally, that means that the founders in robotics for AEC that I look for, many folks will actually approach robotics from an automation mindset. And, I have a master's in robotics, and they taught me how to build robotics into an automotive assembly line. That's an automation mindset. I'm not looking for that. So typically these folks will in the past have managed automation engineers or have been an automation engineer on a team. Typically they would know the Python languages, the PLC languages, C, C++. That's what you typically find in that kind of a background. And then these founders will look for talented sales co-founders. I'm not looking for that. I have learned to avoid that in AEC specifically. For me, what I look for is actually people who have no automation or no robotics background. That's very counterintuitive. I look for people with a background in complex software products who speak a wide array of software languages and who can make informed choices of the best software stack for their robotics companies. And they have learned that because they have managed 50 plus software engineers in a successful setting, in a complex setting. And this is the superhero part of it, the bar is very high for me. Ideally, they are the ones that actually are the talented sales co-founder. So this is my framework for robotics in AEC. If you're building it, if you feel like you're matching a large amount of criteria here, I would absolutely be thrilled to hear from you. Hey guys, thanks for tuning in. Make sure that you subscribe under aecvc.com, and you can also find me on LinkedIn. See you next time.